Alright folks, welcome back to another Math Notes. This is Mr. Jewell. Today we're going to be talking about functions. This is going to be section 1.2.3 in your book. First thing we're going to talk about when we talk about functions is we say, well, what is a function? A function is a relationship between inputs and outputs. And something is a function if there's at most one output for each input. We often write a function as y equals some expression involving x, where x is an input and y is an output. So we're going to, in this video, talk about a couple things related to x and y that you kind of need to keep straight. Put a little blue box around them up here. You'll want to write that down. So x's are your inputs, your independent variables, and your domain. Y's are your outputs, your dependent variables, and your range. So you want to keep all of these terms associated with the x on your graph and all of these terms associated with the y on your graph. We have a little chart here, a table with several points on it, also represented by this graph. And we're looking at an example of a function. You'll notice that for each of these inputs there's only one output. You'll also notice that a couple of these outputs get reused, but that's okay because they have different inputs. Another little test to see whether something is a function or not is called the vertical line test. If you have the graph of a function and you draw a vertical line, a straight line through the function, it should only cross your graph at one point. So it's a really convenient way to test whether something is a function. So this is a function because no matter where I put this vertical line, it's only going to cross my graph at a single point. Okay, I already said this up above, but in the above example, the value of y depends on x, so y is called the dependent variable and x is called the independent variable. Again, keep those terms straight if you can. And we also want to talk a little bit about function notation here. Function notation is great. We use f of x instead of y. It can be a little confusing when you're first introduced to it, but once you get used to it, it's actually really convenient. There's a couple advantages to using function notation, to saying, for instance, f of x equals x minus 2 squared, as opposed to saying y equals x minus 2 squared, mainly because we get to see what we're plugging in for x when we solve it. So if I told you that, tell me what y is when x is 5, if I use function notation, I can actually write f of 5, like I have down here, plug in 5 for x. So do 5 minus 2 is 3. You square 3, you get 9, and get a 9 out. So I'm able to see that when I plugged in 5, I got 9 out. So 5 was my input, 9 was my output. Let's talk a little about domain and range. The set of all inputs for which there's an output is called the domain. So it's all the x's that are valid for your function or for your graph if it's not a function, okay? So the set of all possible outputs is called the range. Again, going back up here. Y's are your range, x's are your domains. In the example above, notice that you can input any x value into the function and get an output. That's right here. So we can put in any x value here and we'll get a y value as an output. And so the domain of this function is all real numbers. That is, you can put in any x value and you'll get a y. And the outputs are always going to be positive because we're squaring it. When you square a negative number, you get a positive number. When you square a positive number, you also get a positive number. So the range is anything above 0. So y is greater than or equal to 0. Because if you plugged in 2 there, you get 2 minus 2, which is 0, and square that, you get 0. So 0 is a possible outcome as well. We have an example of something that is not a function below here. X squared plus y squared equals 1. That's the graph of a circle. We'll talk about that later in the year. And we know that it's not a function because it fails that vertical line test that I mentioned earlier. So if we look at this red line here, it crosses our graph at 2 points, once here in the positive and once here in the negative. So in this case, I've drawn an input of 1/2, or something close to 1/2, and we have 2 outputs. So that is not a function, but it still has a domain and range. The domain in this case is everything between -1 and 1, and the range is everything between -1 and 1. And I put this little box around it to sort of show how this is bound. So our x's are everything between this vertical line and this vertical line. So we go from -1 to 1. And our y's are everything between this horizontal line and this horizontal line, -1 to 1. But again, it's not a function because it fails the vertical line test. So guys, we're wrapping things up here. Take a look at these 4 examples / questions for you to work on here. Find the domain and range of the functions below. I started with A here to give you a little help on there. The red bars are what bound our x's. So our smallest x is -3 and our largest x is +4. You'll notice we have the x value here, -3, and it goes all the way over here to x value of +4. And the blue, which would be our range, binds our function from -2 to +4. And you'll notice that there's no arrows or anything going on underneath there. The function's just in there at those 2 points of a little closed circle. We'll talk about closed and open circles later as well. All right. So take a look. What's the domain and range of this function? Then also go ahead and do it for part B here. And then the last 2, is just asking you, are these 2 graphs functions, why or why not?